got the best spot between you and lunch, so it's like, God. So we're hungry for it. I better be entertaining, otherwise everybody's going to leave in a hurry. Anyway, one thing that some of you, most of you know, but others don't. I used to work for Ron. For 11 years I was in the team, and I was working with Jim and Chris and Ron putting MC1 together. And so when Linda asked me to come and do the conversion after Ron, it's like, oh, I'm going to have my chance to complain and say all the things. Usually what I do is defend the model, so take it with a grain of salt. But anyway, so I now have two hats, because I'm a modeler by training, but I now work for the Nature Conservancy, and they have very specific goals, very management-oriented goals. So the Nature Conservancy has this thing, this 2015 goal, which is 10% of all the major habitat types need to be protected by 2015. And so the question that the CEO asks me is, will climate change make it an unsustainable goal? And that's one heck of a question to answer. And so TNC is the largest private landowner in the world, believe it or not, and it's looking for tools to prioritize climate change adaptation efforts. Tools meaning warm bodies and money that, to buy more land. This is very, very applied. And so sea level rise, coastal preserves, Stephanie's asking me, she said, okay, can we take a model output, look at sea level rise, and can we say, let's dump the coastal reserves because 20, 50 years from now they're going to be underwater, so we're going to lose our investment. Very practical, question. How do I respond to that? Fires and reforestation. TNC is now involved into selling carbon offsets. So they pick certain pieces of the world and then they plant trees and they say, we're going to, if you pay us, we'll manage this and you're going to get credit because the trees are growing. So where should they plant their trees? Question, climate change, can you tell me on a map where we need to buy land and plant trees? Another thing, warming and polar bears. Okay, of course, then they have all the people who have spent their lifetime particularly interested in one species. And they have their little preserve and their species is there. And they're telling me, okay, you're telling me, the climate is changing. Oh my God, the model says there's no refugia in that area. What's happening? Should I do assisted migration? Again, very applied questions that I've never heard before when I was waving my arms with Ron about models. So, I have now a team of 4, which is absolutely fabulous to deal with the entire world. We're supposed to bring climate change. Yeah, right. So we're bringing, the science of climate change to those people. And so we're trying to do something that is going to make a difference. We're trying to be credible, and we're also trying to be as practical as we can. So one of the things, because I'm a modeler, that we're focusing on is putting together a toolbox for conservation practitioners. And so it needs to be applicable to field situation, and the spatial and temporal scales have to match the questions coming from the conservation practitioners. So model experiments, including management options, can help develop new strategies and test the effectiveness. Fast response, easy to use, attractive visualization. We've talked about all this, but this is really where I want to go. I'm saying, we have a bunch of models. Everybody spent their lifetime designing really neat tools. They may not be all able to answer all the questions, but we should be able to answer a few using those tools. So first limitation of the DGVM, since my task today is to talk about DGVMs. It's human impacts. Human impacts are missing in general. Yet humans are part of the system. We've heard it. I mean, every time we go to ESA, we hear about how we're part of the system. We need to deal with it. Yet we haven't done enough about it. There are no pristine environments. No matter what you hear, we all share the same atmosphere, which means you get nitrogen deposition, you get pollution clouds, you get... Humans are there. We've stepped on the ground of every single piece of ground on the planet. It's very difficult to tease out the climate signal alone. We need to be honest and say, when you see a signal, when you see something, it's a combination. The humans are not only emitting, they're also changing, the albedo of the Earth by putting parking lots, by putting cities. We are part of the system, we're changing it. And the credibility of the projections are really on the line. For me, when I come out with a map from MC1, people say, well, for California, it's like, you don't have any human impacts, then I don't want to believe it. And so I'm tired of always justifying that. So this is work by Barry Baker, who's on my team, who's now an officer in REL. He's in Fort Collins. He's an ecologist, actually formed also with the grassland modeling group. And what he's done is he spends most of his life right now in China looking at changes over there. TNC has a big program. And so what he's been looking at, for example, is this is for the alpine various species. And he's been looking at, along an elevation gradient with the various climate scenarios, what happened to this alpine habitat. And what you see is it used to be at this elevation, and in the future it's moving uphill, and it's decreasing in extent because you get less and less possibility to find a habitat for the alpine species. But the thing is, they've been seeing these species, by the way. Lyrics and rhododendron and azaleas are moving into the alpines, and you see the timberline that's really moving up slope. But the problem is, at the same time as climate is changing, there's been new laws in China. Grazing has been removed. Fire has been banned by law. And so how do you say this is obviously a climate signal? It's like you can't say that because you have three very important factors that happen at the same time. And because we've run MC1 without grazing turned on, we can't say that this is really the true answer. And it is really possible, Bob, to turn on the grazing. And we have not spent enough time to calibrate that and make sure that it made sense. But it is possible. It's just we never have enough time and funding and everything else to do it. And so I'm working with TNC California, and it's like I show them the map of fire in the future for California. This is under Hadley. This is under PCM. These are the maps that Jim put in his paper. And you see increases in red and decreases in blue. And when you look at reality, you look at population in Southern California from 1900 until 1990. And then you look at the number of fires per decade during the same time, and there's that nice correlation. Don't tell me that's a climate signal. It might be because people go there because it's nice and dry, but this is California. This is not native, vegetation. This is what's happening. So when I show these maps, everybody says, no human impact, we don't want to look at this. And this is what's happening. I mean, we have, this is a short time period, 1975 to 2004. These are the native systems, this is today. And it's changing as we speak. You get huge changes in albedo. So the feedbacks with the climate are constant. And we have the DGVMs that will tell you what happens to potential vegetation. We have the climate models who are telling us what the future climate is, assuming homogeneous vegetation in each of the pixels that they're running at. But the feedback of what's happening on a daily basis to the Earth in terms of plain albedo, this is not in. And this is important.
Is that agriculture?
Actually, urban areas.
Yeah, that's what I was what do you want to hear?
Yeah. It's parking lots, it's buildings, it's... Okay, second limitation of the DGVM, scaling issues. We've all seen this. This is this GCM. You downscale it and you go to high scale. So this gives you confidence. It looks good. You can see the mountains. Gives you a good feel for what it is. Yes, however, if you have a coastal area here, what you're doing is averaging between the ocean and the land. How reliable is the signal right here? You're mixing simulating the ocean with simulating the land. There's an ocean cell that the climate model sees as pure ocean, and there's a land cell that it looks at and sees homogeneous vegetation. And we're taking that, averaging it, and putting it at high resolution, saying, this is great, we see really high resolution data. How reliable is this? So there's uncertainty there, and we know it. But the managers who look at this map and try to figure out what's happening need to be aware of that. And we haven't highlighted that enough. So at AGU, Chris Daly gave a really good presentation on the macrotopography and complex topography and what happens to projections. This is for the HD Andrews in Oregon. This is January maximum temperature, assuming a 2.5 degrees C regional change from the climate models. And he's changed the number of cloudy days versus sunny days during the year. And this is what he sees on the landscape of the HD Andrews. You see up to 6-degree increase in temperature at the top of the mountain. And you see, in the less than 2 degrees increase in temperature at the bottom of the valley. This is reality. And if somebody talks to me about refugee or about their little species, this is what I want to talk about. I don't want to talk about an average. So the question of the manager, depending what the question is, we're going to have to use different tools. DGVMs may not be appropriate yet to go there because they've never been designed for this level. So this is an example for Idaho. This is a map, the same map, similar map to what Linda showed. Patrick did the average between the 3 GCMs, the 3 scenarios, emission scenarios, pulled it up all together and said the areas in red are where all the scenarios, all the models agree there's going to be a change. In blue, it's only, I don't know, 2 or 3 models together. In white, none of the models agree something's going to happen. And so, you know, TNC Idaho says, okay, let's use this map. Cookie cut for this state, and then you look at these areas, and then on top of it, you put the map of the portfolio for TNC, places they want to manage, places they want to buy. So they go there and they say, oof, nothing agrees. Well, then we don't need to deal with climate change because we don't know. So let's forget climate change. And here it's pink, and we want to buy a piece of land. Ah, we need to pay attention. Then we need to do something about it and put money into, you know, studying the impacts. I mean, is this the way to go with these models? I don't think so. I think scale is really important. We need to explain what this means for the managers because their decisions are based on something that may not be what they think it is. The third limitation is quantify the uncertainty. And so somebody was asking about the uncertainties. You have uncertainties for climate scenarios. We know that the GCMs are not good at projecting PDO and El Nino, and Ron just explained to us how important those things are. Extreme events. GCM do not predict extreme events yet. That's going to be a big uncertainty in the projection. Emission scenarios. Everybody says, you're giving me too much of a bracket. This is, you know, A2 versus B1. Yet, it has nothing to do with modelers. These are economic and social choices. If a manager can tell me how much emission will happen from industry in China, in Europe, and in the US 20 years from now, I can give them a much better estimate of what the model says. There will be. The impacts model have inherent thresholds. That's what Linda and I were talking about in the discussion before. It's like, this is something we rarely talk about. We average across time, across space, but we don't show where the weaknesses, where the thresholds are in each model. And each model has its own thresholds. We always calibrate with this historical data, yet Ron has a slide I didn't show today saying the future may not replicate the past. So just be aware of that. All our models are calibrated with something we believe in it today, with reality, but we are not 100% sure this is going to continue that way. And the assumptions are really important. There's a CO2 impacts, and Ron talked plenty about it. Somebody was talking about white rot and red rot. How about mycorrhizae? If you start replanting in the Pacific Northwest and you have a soil without mycorrhizae, it ain't going to grow. CO2, water, whatever, if you don't have mycorrhizae, it ain't growing. Complex topography, it's very important. I showed you Chris's slide. This is something, and I was talking about this with Chris at AGU. It'd be really neat to create a layer for our output, maybe derived from elevation, showing if it's really complex terrain, the projections are weaker than if it's really, you know, a plain or whatever. Grasslands are always easy to simulate. Humans, grazers, and pests are not in our model, and you know, insects we've talked about. Grazers is something we can do, and humans. So some of the challenges for modelers. We always show ensemble of climate scenarios, but we rarely show ensemble of impact models, and we've been talking about VMAP. It's like we need another one, obviously. Gaps in knowledge. Below ground is still a black box. No matter what, all the models have that huge black box. Acclimation is something we don't talk about. And yet, at the DGVM level, because we have plant functional type, it's a little bit easier to deal with. But if you're talking about species, we need to talk about that. And, adaptive coevolution. Current models are based on old technology, you know, centuries, 30 years old. Despite influx of new approaches, like I put data acquisition, data assimilation, we need to be creating new tools if the managers are really trying to, or starting to be really interested in models. I think creativity is really interesting, an interesting thought. And Miles' suggestion of using, you know, DGVM output to go into VDDT, I think is a good idea. It's one new way. Because as you've heard, the DGVMs are not going in to be simpler. Okay, so the next step, do we toss the models out? We have all seen the movie. The Nobel Prize has been given, so global models have served their purpose. They remain the best synthesis tools we have today. Look at us, we're all around the table, we're actually having discussion and comparing notes. They should be used to look at disturbance response because the long-term future is uncertain. And that's one thing I'm really interested in, is taking those big models and disturbing them. And you know, people like Peter Cox have now ensembles of 10-year projection, and I think if we can go that way, they're initialized with actual conditions instead of going into really uncertain future for 10 years. He actually shows a full range of possibilities depending on emissions. And I think if we do that, if we pick short-term climate scenarios and we disturb the models, showing, for example, extreme events. So what happens to your system if you have 2003 summers in a row, you know, in Europe? What happens to the system? These are things we can do with the models, and yet we have not done it yet. So that's another option that I'm throwing out there. That's it.
Thank you very much, Dominique. We'll take a few questions now, and then we'll take a break. Greg.
I just want to compliment both of you in regard that your model is taking into consideration disturbance regimes and events. And I said that up front, that's one thing that's I'm really keen on. In the eastern United States, I'm hitting this quite hard, but I think that's one of the reasons I'm here.